Hello students, this is Varun. We already have done with the concept of continuity and now we move to the next topic, that is differentiability. Differentiability is a basic tool in the science of calculus. It helps us to measure the rate of change of variables. It also enables us to find maximum and minimum values of differentiable functions. Now we start with the first topic, that is differentiability at a point. Let there be a real valued function defined on the open interval AB and C belongs to that interval. Then function is differentiable at x equals to C if and only if limit x approaches to C fx minus f of C whole divided by x minus C exists finitely, and this limit is called derivative or differential coefficient of the function fx at x equals to C, and it is denoted by f dash x or d f of C, means derivative of function at x equals to C, and sometimes d upon dx of function at x equals to C. And the value of this limit is what we call the derivative of the function at x equals to C. As per definition, we can see that function is said to be differentiable at x equals to C if this limit exists finitely. And we know that a limit exists finitely if and only if its left limit is equals to right limit at that particular point. So accordingly, this limit will exist if left limit at x equals to C, which is denoted by limit x approaches to C negative fx minus f of C whole divided by x minus C, is equals to right limit at x equals to C, which is denoted by limit x approaches to C positive f of x minus f of C divided by x minus C. Now let us solve this left limit and right limit separately. For left limit, limit x approaches to C negative fx minus f of C whole divided by x minus C. We will go for the substitution and let us put x equals to C minus h such that limit h approaches to 0. So that is how we get limit h approaches to 0 f of C minus h minus f of C whole divided by C minus h minus C. Here C and minus C will get cancelled and we are left with limit h approaches to 0 f of C minus h minus f of C whole divided by minus h. Let this be equation number 1 and let it be 2. In the same way, we will find the value of limit x approaches to C positive. So by substitution and following in the same way, limit x approaches to C positive fx minus f of C whole divided by x minus C, it will become equals to limit h approaches to 0 f of c plus h minus f of c whole divided by h, and let this be number 3. Now from 3, 2 and 1 we get limit h approaches to 0, f of c minus h whole divided by h is equal to limit h approaches to 0, f of c plus h minus f of c whole divided by h. Means function f is said to be differentiable at x equals to c if this condition is satisfied. The value of this left limit is what we call the left hand derivative and is denoted by L f dash c, left hand derivative of function at c, and this value of right limit is what we call right hand derivative of function at c. So we can conclude that a function f is said to be differentiable at x equals to c if its left hand derivative is equals to right hand derivative. Now let us try to understand the geometric meaning of the same. Let there be a function defined on open interval ab, and let p with the coordinates as shown be a point on the curve which is y equals to fx, and let q and r be two neighboring points to point P with the coordinates of q, that is c minus h, and f of c minus h, and that of r c plus h and f of c plus h. And here slope of PQ is given by y2 minus y1 divided by x2 minus x1. So that is how it will become f of c minus h divided by minus f of c divided by minus h. And in the same way, slope of PR, that will become f of c plus h minus f of c whole divided by h. Now we know that tangent to the curve at point P is the limiting position of chord PQ when Q tends to P, and it is also the limiting position of RP when R tends to P. Now since H approaches to 0, so both point R as well as point Q, they will tend to point P, R through right side and Q through left side. As both Q and R are tending to point P from left hand side and right hand side respectively, so what will happen? Both chords PQ and PR will become tangent at point P. Since both PQ and PR, chord PQ and chord QR, become tangent to the same curve at the same point, so their slopes will be same. That is why we can equate these two. So here we write now function is differentiable at x equals to c. When limit h approaches to 0, f of c minus h minus f of c whole divided by h equals to limit h approaches to 0, f of c plus h minus f of c whole divided by h. It should be minus h. And we can conclude that there is a unique tangent at point P. If function is differentiable at any point, then there must exist a unique tangent at that point. Or we can even say that function is differentiable at a point P if and only if the curve doesn't have P as a corner point. Now regarding this, that's P as a corner point. From next video we will clear this concept as well. So today we have studied that a function is said to be differentiable at a point C if at that point the value of its left hand derivative is equals to right hand derivative. Left hand derivative is given by limit h approaches to 0, f of c minus h minus f of c whole divided by minus h, whereas right hand derivative is given by limit h approaches to c, f of c plus h minus f of c whole divided by h. Thank you.